So hello everyone, and today we're going to create a matrix class in C++, in C and C++. It's going to be a basic matrix class, and we can expand upon it in the future, make it support more matrix functions, stuff like that. So let's start by creating a new file, and we're going to name this matrix.h. Matrix.h means it's a header file, which is where we're going to declare our matrix class but not define it. Things define it in a separate file. This is good practice. You don't usually want to define everything. So define everything in your header file. You want to declare it in your header file and then define it somewhere else. That's the standard practice, and that's what we're going to do. So in this header file, we're going to put everything in a namespace called matrix, and integrate a class called matrix. So remember, this class always has to terminate with a semicolon, and we can do this. And what we're going to do is we're going to declare 4 private variables that only member functions of this class can use. So in private, we're going to declare size t, which is just another name for an unsigned long integer. If you don't, instead of typing unsigned long int something, you can just type size t something. So size t height, we're going to this underscore height because it's a private function, and a private variable, and size t width. And we're going to present a matrix as a vector of valarrays. So vectors are C++ equivalent of arrays in C, but smart, or lists in Python. So you can they are not static sized, they can be variable sized, so you can change the size. So we don't need to do that here. Once we declare a matrix of some size, it's going to stay that size. But it'll be useful because it has functions like pushback and popback, just adding something to the vector and taking something away from the vector. Valarray is a vector, but it's guaranteed that every element of it is going to be an integer. Or not an integer, a numerical type, like an integer, or a double, or a long, or float. So you can do numerical operations on them. For example, if you take a valarray a and multiply it by 3, every element in that valarray is multiplied by 3. This is going to be useful for us because we need to do that. Let me switch off vibrate on my phone. And so for that, what we need to do is first we need to include both vector and valarray. Include vector and include valarray. So, and going to do std vector of std valarrays of doubles is going to be called a matrix. And the last private variable we're going to declare is going to be a boolean. Bool is a square. So this variable is when we create a matrix with some height and some width. So we're going to check if the height and width are equal. If they're equal, it's squarably true, so we will know that the matrix is a square matrix. And if it's false, we'll know the matrix is not a square matrix. And you can always, check them manually, but this is going to be a lot easier, and will come in handy when we have to do such things as find determinants or do some operations that only can be performed in a square matrix, such as inverting a matrix or finding the adjacent matrix of a matrix. So that's it for private functions and private variables, that is. And for public members, first we need to declare a constructor and a destructor. So the complement sign, the name of the class, makes a destruct. And this makes a constructor. So a constructor is the function which we are going to use to create an instance of a class, and this is going to destroy that instance of a class and free up the memory used by that. So the constructor is going to take in two parameters of size t and size t, which are going to be the height and the width matrix we need to create. And we're going to declare a second constructor, which is going to take three parameters of size t, and a value, which we're going to initialize every element in the matrix to that value. And so we can do. But I think that's it for here for now. Then let's just declare another function, print. We're going to use this print our matrix, and it's going to create a new file called this matrix.cpp. It's going to have to be the same name as header file just created, and we have to include that header file here. Have to use double quotations instead of the angle brackets we normally use, because this is a header file that you've declared, and it's a local header file instead of the compiler providing it to you, which makes it a global header file. And so you can't open include or angular bracket include the header file, and so you have to use the quotations. So we're going to put everything here, and also the same namespace matrix. And what we're going to do is into the matrix. This is our first constructor, size t, and size t is going to be height and width, and first we're going to set height to height and width to width, and then we're going to set a square to height equals width. So if they're same, this becomes true, so a square is true. If they're not same, this becomes false, which makes the square false. And class we're going to so now we have this vector of valarrays, but it's empty. It's an empty vector of empty valarrays of size 0 and 0, so there's nothing in it. You can't put anything in it because it doesn't exist, sort of. So what we're going to do is expand that vector and expand that valarray. So how we're going to do that is we're going to create a valarray called a temp. So we're going to create a temporary valarray. So std we're going to have to include all that hyperlink here. So let's try this. Std valarray. No, we do not. Std valarray of doubles. Of double, we're going to name it temp, and we're going to resize temp to width. So what this is going to do is we're going to create an empty valarray temp here, and then we are resizing it so it is the same size as we need the width of the matrix to be. So because each of this is a row, it needs to be of the size width. So each valarray is a row, and this valarray is of the size width. So what we can do is we can iterate on I equals 0, less than length. This was I. What we're going to do first is we have a vector. This is our vector, not length, it's height. So let's get this confused. Height. So matrix dot pushback temp. So this is for I is equal to 0. When the matrix is empty, we're going to push this valarray into it. So the matrix is of size 1. The vector is of size 1. It contains 1 temp valarray. It's empty. What we can do, instead of putting a loop in another loop, first we can print I equals 0, I less than width, and incrementing I, we can temp I equals 0. So we need to initialize temp array to contain all zeros. Width, contain all zeros. So, and this is a row of all zeros. We're going to push that onto our vector of valarrays. So until it reaches height, so it will be of length height, and it's going to contain height number of rows of all zeros. So that's it. It's for first creator, and from second constructor, we're just going to copy this code. What we are going to do is, so for initializing this to 0, we're going to take an parameter called val, and we're going to initialize it to that val. So that's it for our two graces, and we have to define the destructor class. We don't need to put anything in there because all our components, which are these four, they all destroyed themselves in the end. So we need to delete them. If we had a array of doubles here instead of vector of valarrays, we would have had to delete that here. So it's matrix, complement matrix. And let's leave it empty. Let's define a print function, so void function of the matrix print. So what we're going to do is print I equals 0, I less than height, not heat, height, and I plus plus. And for int j equals 0, j less than width. No, not 2 semicolons, j equals 0, j less than width, and incrementing j, semicolon now. And then for here, what we're going to do is we are going to display. We need to include IO stream here, so we should include IO stream. And we're going to put our matrix ij and a space following that. What we're going to do before the start of each row, we're going to also put out an opening square bracket to make it look like a matrix, and at the end of each row we're going to put a closing square bracket and a new line. That's it. And after we print that, we're going to another new line, std end line, and that's it. We can create a matrix and print them now. So let's try it out. Let's create a file called test.cpp, and we have to include a header file here, so matrix.h and int main, and here First, let's create a matrix. So matrix A is going to be a matrix of size 3 by 2. It's going to have 3 rows and 2 columns. And let's initialize this to all ones. Hey, 3 to 1, that looks nice. So now we're going to print A, and we're going to exit. So we have to compile this. I'm using Clang. You can use GCC or MSVC. Personally, I'm too lazy to set up MinGW or to use GCC, and MSVC is steaming a pile of shit. So we're going to use Clang here. So Clang, what we need to do is we're going to put test.cpp, and we also have to compile the file where we define everything we declared in our header file. So we have to put matrix.cpp here, and /o, which is and test.exe. So our file is going to be named test.exe. So there should be no errors or warnings. It compiles, so let's run test. We found a matrix of 3 rows and 2 columns, and we printed that. So what we can also do is transpose the matrix. So before we do that, we need to declare a few methods. So it's going to be size t get height and size t get width. So because height and width are private, they can be accessed by anything. It's not a member function of the matrix we need working with. So we're going to declare these 2 member functions. They're going to return the size for us. So size t get length. So matrix get length. Get height. We need to return height. And we're going to copy and paste the same here. And it's going to be get width. And we're going to return width. And the last thing we're going to do is we're going to overload this operator, the subscript operator, the index of operator. So at the moment we can't access a matrix. So if we declare a matrix A, we can't access individual elements of A like this. But overloading the operator, which is making the operator do something you want. So when someone uses this, what we have to do is ideally return the row. And with this, return the element. So what we're going to do is we're going to make the operator return a valarray. The reference of a valarray of doubles operator, and there's going to be one value inside the operator which we're going to call index. So we're going to pass a valarray when someone uses this operator, and then when they use the second this, they're going to be accessing the individual end of the valarray. It's going to be simple to do that. So let's just copy this and paste this here, and it's going to be matrix operator. We're going to return matrix of index. That's it. So we have everything we need, and then let's just declare a transpose function that is going to return a matrix. So back here, matrix transpose. So we're going to create a new matrix first, and there's going to be named temp, and it's going to have a height of width and a width of height. Because transpose, when you rotate something 90 degrees, so its height becomes its width and its width becomes its height. So every row becomes a column and every column becomes a row. And so in this new matrix, what we're going to do is we're going to iterate over the elements for our matrix. So for int I equals 0, I less than height. This height is going to be underscore height. And for int j equals 0, j less than width plus j. Again, this is going to be underscore width, not just normal width. And we need to do temp of ji, not ij, ji is matrix ij. And we are going to return the temp matrix. That's it. I think instead of using this loop, you can just do temp I is equal to can you do that? Yeah, let's just stick to what we did before. So this is our transpose function, and it should work. We should also be able to manipulate individual elements of the matrix now, so let's do this. Let's set A11, that is the second element of the second row, to 5. And then we're going to transpose A, and because transpose written in the matrix, we're going to spring that. So if you did everything correct, this should compile with no errors and no warnings, and it doesn't. It's temp ij minus, and it should be temp ij equals. So that's why you shouldn't go, there are warnings. There are warnings for a reason. And now we're going to run a test. See, we set this element to 5 and then we transposed it, so this row becomes column, and there we go, the 5. So we created the matrix class and we've transposed it. And in future videos, hopefully, we're going to expand on this concept and write functions to return the determinant and the inverse and the adjacent matrix, and we're going to define multiplications of two matrices and addition and subtraction of two matrices. The multiplication of matrices by a scalar value. A scalar is just a number. So have a nice day, and I'll meet you in the next one.